Hi everyone. In this video I'm going to show an update to the Telemetry Viewer program that I've been developing. The main new feature is support for TCP and UDP, and that means you can now visualize data that is coming in over Wi-Fi or Ethernet. So a couple days ago I did a video on how to wire up an Arduino Uno and an ESP8266 module, and that's going to be one of the demos, which you can see here. The top chart is a light sensor, and if I kind of cast a shadow with my hand, we can see that responding. And the bottom chart is a thermistor, which is a temperature sensor. And if I touch it, it will climb up, and if I let go, it'll fall back down. And then, like before, I have my balancing robot demo, which is also wireless, but that one's just a Bluetooth UART, so that is not really anything new there. But I'll show it again because it seems to be kind of popular. So, turn on the motors. So you can see the charts updating live with telemetry. And so, like before, I have accelerometer data here, gyro data here, the PID components of throttle shown there, and then I have a histogram of the pitch as well as it's shown as a gauge, so you can kind of see that responding. Alright, let's take a look at some of the new features that I've added to version 0.5 of Telemetry Viewer. So perhaps the most useful addition would be support for TCP and UDP communication. And so when you open the program, you'll see this familiar message, and down at the bottom right, as usual, you have settings for connecting to the device. And there are two new options, TCP and UDP. For now, I'd recommend you stick with UDP. The TCP support that I've added expects everything to be funneled through one TCP connection, which isn't going to be very reliable if you're running it over a network. So I left it in there, but I wouldn't really recommend using it just yet. So yeah, use UDP, and then you can specify a port number, and I have 8080 in use right now, talking to that Arduino that you saw a couple minutes ago. So let's try another port, and then you click connect, and like before, you define your data structure. So your first CSV column, you can give it a name. You can do light sensor. Like before, you can pick a color. You can give it a unit if you want. And the Arduino has a 10-bit ADC, so the full scale reading is 1023, and on a 5-volt Arduino, that'll be 5 volts. And you click add, and that will automatically do the scaling for you to convert the ADC reading into a voltage. And then I have the thermistor, which is a temperature sensor. You can give it a color. And then same thing, I'll convert it into volts. 1023 corresponds to 5 volts. And that's basically what you saw before. And I've added a code template for that Arduino and ESP8266 breadboard project that you saw at the beginning of the video. And so like before, it's a template you'll have to edit. And what you want to do is you want to put your Wi-Fi network name here, your Wi-Fi password here, and then you'll want to use the IP address of your computer here. And how it works is my software will try to figure out the IP address of your computer. However, if you have multiple network devices, it doesn't know which one it should use. And so, for example, this computer has 3 network devices. So there are 3 different IP addresses. Obviously, you can only have one here, so you pick whichever one happens to be correct. In Windows 10, if you right-click on the Start menu and go to Task Manager, if you go to the Performance tab, you'll see your network devices. So this first one happens to be for VMware, and it is the one ending in 254.1. I have another one for VMware ending in 142.1, and then I have my Wi-Fi, which is ending in 1.200. So that's where these three numbers are coming from. It'll be different on your computer, so anyway, just figure out which IP address you want to use. In my case, it would be the Wi-Fi address, which is 192.168.1.200. And then again, the port number. So because I typed in 1234 over here, it put that over here. And then basically, if you're sending integers, you would need to edit these two lines. So for example, you might put like an analog read over here, or whatever math you need to do to calculate the number. And this is the loop you would use if you're going to do integer telemetry. If you want to send floats, you can use this loop. You know, you'd edit these two lines, and that's pretty much it. It'll do all the work to convert it into text and then transmit it over UDP. And then these are all the commands that do the actual work, and I've covered this in an earlier video, so I won't go into too much detail, but I'll put a link to that video in the description if you want to take a look at it in more detail. Anyway, so you would basically, select all this code, Control-C to copy it, open up the Arduino IDE, Control-V to paste it into there, and then edit those lines. And you click Done, and it will tell you that the UDP server is running and to send telemetry to one of those IP addresses at port 1234. And as soon as it starts to receive telemetry, this green message will go away. If you want to hide this notification, you can just click on it and it will fade away. And then again, like before, you can add a chart by clicking and dragging. So if I click and drag, I can make a chart. But again, I don't have anything transmitting on port 1234, so there is no data, so there's nothing to see here. So let's go ahead and close or I'll minimize it. And let's go ahead and look at the balancing robot, because I have a lot more, I guess, interesting stuff to look at here. So another feature that I've added is kind of tooltips on charts. So if you move your mouse over a chart, it will now kind of give you these readings of the values under the cursor. And for a histogram chart, it will show you the bin that you're looking at, how many samples fell into that bin, and then of course the relative frequency for that bin. If you click on settings down here, this is where I've moved some of the user interface settings to. And if you don't want tooltips, you can just uncheck that, and then now they're gone. If we have a chart with only, so with auto scaling, that's going to be kind of hard to see jumping around, but if you have a, here, let me rewind, there we go. Okay, so if you have a chart with only one data set, the tooltip will kind of sit on that line, which in this case is bouncing around. And if you have a chart with multiple data sets, then it'll just draw it right at your cursor. Okay, so there's also a few more features here. I've covered in an earlier video the Logitech smooth scrolling, and so if you have a Logitech mouse with a high resolution scroll wheel like I do, you can kind of see that I get very fine scrolling ability. It's a very high resolution scroll. It isn't your typical click 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 type scroll wheel. You can also disable that, and then it'll work like a typical mouse where it'll kind of jump as you move. You can turn OpenGL anti-aliasing on and off. Probably won't show up very well in the video, but if you watch it in 4K it might be a little more obvious. Basically, if you have a less powerful GPU, or if you want to save some battery life on your laptop, you can disable anti-aliasing. You can also draw the FPS and period, which we'll draw down here. And so I'm getting basically 60 FPS. And this last option is really more for helping me out, but I left it in there because why hide it? If you want to see how much processing power it takes to draw a chart, you can click here. It will tell you to click on a chart that you want to benchmark. So I can click here. And we now see a measurement of CPU time and GPU time. And obviously it's not taking very long. The GPU time may be inaccurate. If you're not familiar with how the graphics pipeline works, it's because when I capture the starting timestamp, if the pipeline is empty, it's going to start counting up time even though the GPU isn't doing anything. So that value may be higher than it should be. So you kind of have to know a little bit about OpenGL and how the graphics pipeline works to properly interpret that. But anyway, it's there. So yeah, you probably don't need to use it. And like we saw earlier, I now have kind of notifications that'll pop up here up top. So like this green one. Basically what will happen is whenever there's a notification, it will blink that color or whatever color it happens to be to notify you of an issue. And then in this case, like if you click on a chart, it will automatically fade away. So I did that because before I'd have pop-up windows, you had to click on OK. And I wanted to kind of make things a little bit more user-friendly where it doesn't get in your way. It's just sitting there at the top. You don't have to acknowledge it. You can just keep looking at your telemetry. Alright, those were basically all of the new features in this version of Telemetry Viewer. If you haven't seen my earlier videos, check them out. They kind of go into more detail about how to use the program. There weren't a whole lot of new features in this version, but I haven't had a lot of time to develop more for it. So I thought I'd release what I've got now, and as I have time I will make more updates and share them with you. I hope this video was interesting and helpful. If you have any questions or comments, leave them down below. And if you know anybody that might benefit from it, please share a link with them.